All right. All right, we ready?
Yeah.
All right, so we're going to be going over it on lesson 11. So, all right, so lesson 11, question 1. List at least 3 characteristics of students' T distributions. They said it has to be a symmetric shape. The mean has to be 0. The shape depends on the distribution, degree of freedom, and the tail is more area.
Yeah.
Okay. How many degrees of freedom generally does? What's the formula for the degree of freedom? And that was df equals n minus 1.
Yes.
Okay. The formula, the sample mean the x bar plus or minus the t times the sample's deviation, I don't know what they call it, the s, over the sample size, which is over the square root of the sample size. Basically the same thing as the z confidence, the other confidence. Yeah. Okay. What are the 2 differences between the 1 sample T confidence and the 1 sample Z confidence? Sigma.
I got one that the sigma is not known.
Uh-huh.
Or the standard deviation, whatever.
Yeah.
And that you can't use the applet.
Yep.
That's what he said. Yep. We cannot use the normal applet to compute t-scores.
Yep. That is correct.
And so the student T distribution rather than the C score.
So that has to be given to us in a sense, right? Because I didn't see any way we could. Okay.
When I was looking at the tutorial video, he said they should be giving us that.
Okay. When conducting a hypothesis test for a single mean with a sigma unknown, what is formula used? Well, I got what it was written, T equals x bar minus the mu over the sample deviation over the square root of the sample size.
Yeah, that's what I got.
Okay. All right. What are the requirements that are needed to make? Number 6. What are the requirements that need to be met to conduct a hypothesis test for a single mean when sigma is unknown?
Simple random sample.
Mm-hmm.
And the bar X has to be normally distributed.
Right. Okay. So now we're going to the next one. What are the requirements for creating a 95% confidence T interval? I said just refer to number 6. It's the exact
same answer.
Yeah. All right. Number 8. With the data above, calculate the margin of error created by a 95% confidence interval to estimate the mean age of all clients who buy an investment property. Input the numbers you computed in number 7 of part of 1 in the confidence interval. Show your work below. The T-score. The T-score is 95% confidence interval from the T distribution, 14 degrees of freedom.
Now, if I'm not mistaken, his answers don't match the answer key answers.
It was off just a tad. It wasn't much. He said it was off by 0.001, and he says in your test all the tests and homework will be accepted.
Okay, let me make sure. Now I remember him saying that, but so for number 8.
Mm-hmm. So I did
on the video. He said 46.7 and 8.83.
Uh-huh.
And on our answer key, it's 41.845 and 51.622.
Mm-hmm.
So those don't match at all.
I just I just did the calculations, and my calculations came out to 41.845 and 51.
Okay, good.
Sometimes,
I want
yeah. So the formula is 46.73 coming from the, plugging into the quantitative, whatever, plus or minus 2.1448, which is what the T.
Oh, you know what? Never mind. I can't even read my own notes. Sorry.
Not a problem.
Never mind.
Times 8.83 over the square root of 15.
Yes.
All right. Okay, so that will give you a 41.845 for the lower and 51.622 for the higher. And then with the 99 percentile, given everything's the same. You change the T to 2.9768, which was given up to us, and it comes out to 39.948 as the lower and 53.518 as the top.
Yep.
And then you can put it in here. Let me do a screen share. Then I put it. Then I opened up this one, and this is where I got the other information. So this is what the answers came out to when you inputted all those in. So, all right. We're going to sort of keep it there. All right. So that will. I just plug that in, and I can put for the 99. I just put right there too. So back to 11. How does the margin of error of 95 and confidence interval compare to the 99? You want to take a stab at that?
Well, I believe if it's smaller, if the confidence of interval is smaller, isn't that what it's called?
Yeah.
Then it is smaller, and if it is bigger, then it's bigger.
Yep, they correlate the same direction.
Right.
All right. So going to 12, then state the null and alternative hypothesis. So, well, by doing 47, you're taking that as the hypothesis of mu equals 47, and then alternative of the hypothesis is not equal to 47.
Yes.
So we took that sampling from there. So the mean is right there. You can see 46.7. He put 7.3. You could do as low as 3.3 minus the 47, which is what we got. 8.83 right here over the square root of 15 comes out to a T of negative 0.118.
Yeah.
Okay. State the degree of freedom. Again, that's 15 minus 1. So it comes out to 14.
Mm-hmm.
We could do, this is the only time he said we could use that, the p-value. I mean, the applet. So, we could go in there. And what is the p-value is, hold on. So, sorry. Why is my, all right. So here's the p-value right there, 0.908. So that means that your decision, do you reject or fail to reject? We fail to reject it because the phrase goes, p-value is greater than the level of significance. We fail to reject the null hypothesis.
Correct.
Present your conclusion in English sentence relating to the result of the contents on the problem. What did you get? I'm not good at this.
That we have insufficient evidence to conclude that the mean age of this realtor's customers who are buying second homes is different than the natural average.
So in a nutshell, we don't have enough evidence.
Right, and he said that we need to say insufficient because we don't know.
See, that was what got me. So, okay. All right, so we're going to Well,
Because originally I just said there was no evidence, but he said that you need to say insufficient evidence because you don't, it's a hypothesis basically.
okay, it's insufficient. Okay, that's good to know. Yeah, because have you taken? So I guess we can stop broadcasting now, right?
Yeah.
All right, cool.